Well, the slope of the line, you know what, I'll wait. There we go, we got a slide for that, okay? The slope of a line just describes how steep it is, really. But for us, we need to remember that it's a ratio, all right? So it's a ratio where, that's a colon right there, where you compare your y values. Let's hope this works today. Compared to your x values, okay? Well, even more specifically, it's the changes in the y value compared to your changes in your x values, okay? Now that may not make a lot of sense right now. Hopefully we can clarify that on a graph, okay? But when a linear relationship is graphed on a line, you call the constant rate of change of the line the slope of the line. Now this is important, by the way, because of the next section. The rate of change actually is the slope. Bam. So we don't always see it on graphs, of course, but sometimes we see it in word problems and tables and other scenarios. So I like to think about it in terms of stairs. In fact, you guys will see me draw stairs, which I think I have already in this unit. But if we think about it in this staircases, hopefully it kind of makes a little bit more sense, right? Like if we looked at these three staircases, we would ask, well, which of these would be the steepest, which in turn would translate into which one has the most slope, right? So yeah, slope is kind of like a set of stairs. That's true. And some people would look at this and be like, well, for example, the 8 there, right? It's a big number, so it has to be the biggest slope. Others would say, well, if this one goes up 6 inches, therefore it's the biggest slope. Well, remember, it's neither one or the other individually. It has to be a comparison of both, all right? Here's what I mean, is you have to say, well, you got to look at the change in y and the change in x. And y is a vertical change and x is a horizontal change. Just like the number lines, the x and y axes, xi are, whatever, okay? So this one, for example, as a ratio would be change of y, that's 5, and a change in x's, or horizontal change, that's 5. And we know that would simplify to be 1 right there, right? Now, since we're looking for the steepest staircase on this one, we would be looking for the one that has the greatest value of rise to run, or change in y's to the change in x's. So this next one, right? It goes up 3, and then it moves horizontally 8. So that would be a ratio of 8 to 3 on this next one. And if you wanted the decimal on that, maybe like 2.7, I guess. I did round that, by the way. Not that it matters, because this next one's bigger anyway. So this is a rise, or it's a, wait, on that last one I did that backwards. Ignore that garbage. It's supposed to be 3 to 8. Yeah, something seemed a little off on that one. 3 to 8, well, that's a much smaller value there, actually. That'd be 0.375 on that one. Okay, that's much smaller. Well, I guess that's a good mistake to make right now, because it's early in the lesson. So just make sure you have those organized properly, right? Because I don't know what that guy's doing right there, putting the 8 in the numerator. But it's always the vertical change in the numerator, okay? So like this next one, the vertical change is 6, so that's our numerator. The denominator is the horizontal change, that's 4 in this case. And 6 over 4, as a decimal. I'm using the decimals just because it's a little bit easier to compare. We don't have to find common denominators. But we see that 1.5 is bigger than 1, and it's also bigger than 0.375. So that's why it's bigger. It's not just that it goes up 6, but it's that it goes to the right 4 in this case, because if we continue to extend this out, and maybe you said this was 6 inches right there, well, now it no longer is the steepest. It would be tied in steepness with staircase 1. But, of course, it wasn't extended that far. So, as is, it is the steepest. So, again, I like to use these stair steps when we're looking at graphs, and you guys will see this. I recommend using them as well, so that you can actually quantify how far your up and down movement is and how far your left or right movement is. But just so you guys know in the future, as we look at these, I'm always going to be going to the right. Okay? If I always know that I'm going to the right, and I'll expand on this a little bit more here in a second, then from there, I can determine if I need to go up or down, which will also determine if the slope is positive or negative. And since these ones, I would say we're all going upwards, they're all positive. Okay? And again, this is if you specifically go to the right all the time for your slope. So yeah, here's a graph. It just wants us to find the slope. And I'm going to use a stair step. Okay? Well, when we use a stair step, we got to be kind of careful. Okay? What I need is for this red line to go through one of the grid corners. Okay? Again, that's so that I can accurately quantify how far up or down or to the left or to the right it goes. Here's what that means in a little bit more specific terms. Is I don't want the line to go through like almost the corner. You see, like right there, right there, and right there. It's pretty close to this grid corner, which would be, right there. But it's not right on it, and I need it to be right on that corner. Okay, like for example, this one is. Okay, so this I'll color it a different color there, purple, right? We'll say that purple one is usable because I can actually figure out the exact coordinates of that point without any type of estimation at all. Whereas these two orange points right here, I would have to do some estimating on those. Okay, same with this one. You can say, well, that looks like it's about half. But is it exactly a half? I don't know. And it's hard to tell unless it goes through these grid corners, okay? So let's pull this out a little bit. So we should examine this a little bit further, and just if we look through where the red line goes through the grid lines, we can see that it goes through the grid lines through all these orange points. But again, that's not accurate. It would require some estimation on those. But I do see that it goes through this point right here. Now, going back to what we learned last Thursday, I think, maybe it was last Tuesday, is these are the x and y intercepts. Okay, it just happens to be this case on this one, and I don't really see any other points that I could use. At least that's showing right here. So here comes the stair step, and the stair step's kind of different in size on these. You know what? I'll use a different color on this, like this one. Okay, so there's my stair step. I made it in green just so we don't get the colors confused with the orange business. Well, I want to know how far it goes up, and then how far, again, for me it's always going to go to the right, and that's going to be a ratio that I can make on this, okay? And the ratio I'm going to write as a fraction, of course. Well, from this, and again, I think we've kind of done this before, I can see that this green line, it goes from one point to the next. I would go up, and in this case, how many units did I go up? Well, starting here, I went up 1, 2, 3, 4. So it's up 4, and since it was up, that is a positive 4 as my numerator right there. Well, that's my change in the y values. The change in the x values, this one shows that it goes here to the right. Well, how far to the right? Well, starting at this one, we'd say it goes 1, 2, 3, 4, 5 to the right. Now, since it's 5 to the right, I keep the 5 positive. And the last thing I would do on this is just to check and see if this fraction could be simplified. For those of you that think, maybe you want to turn it into a decimal, for the most part, we want to see these as fractions. And the reason that is because if I keep this as a fraction, then it specifically shows me the change in the y's, which is in purple, and then the change in the x's, which is the red. Okay. Now, in the future, just so you guys understand, we are going to be calling the change in y's the rise, and the change in the x's, that's called the run. All right, so rise goes up and down. Rise is for y's. Run is for x's. X is for run. Not the runs, just run. So 4 over 5 on this one. Rise over run. Rise is 4, run is 5. I probably wouldn't show the slope as mixed numbers just because an improper fraction is a little bit more specific anyway. Alright, so find the slope of this line. Okay, so again, we got to find 2 points on this blue line that we can actually quantify, right? We can actually say for certain what the ordered pairs are for this line. Well, this one's not too big, so I can find all the points that we could use, but again, I only need to use 2 in order to make a stair step. Alright, so I can see it goes through this point. That would be negative 5, 0. It goes through this point. That'd be 0, negative 2. And then this point as well, which is at 5, negative 4. Now again, you don't have to use all 3, definitely. You only need to use 2. It just doesn't matter which 2 you choose, okay? Now if you choose the 2 points that are closest to each other and you accurately identified them, then there will not be any need to simplify your fractions most of the time, okay? But if you choose 2 points that are not immediately close to each other, like these 2, then you'll have to reduce the fraction when you figure out your slope. Okay, let me demonstrate this. Now remember, I always go to the right, so I'm going to start with the one on the, I would say to the left. On this case, it's at negative 5, 0. Okay, so that means that my stair step would show going down and then to the right. Again, I always go to the right because it keeps my denominator positive. Not that that matters, or that it should matter in the homework. But from here, I've made my stair step, and yeah, we can see that if you wanted to, you could have said, well, couldn't you went that far and that far? Yeah, you could have. All right, but I didn't, just because we're trying to show that if you need to simplify the fraction in the end, then do it. So I started at the point right here, and then how far, and it does go down, by the way, so we'll identify it's going down, which is going to make the numerator negative. How far down does it go? Well, 1, 2, 3, 4. It went down 4. All right, so in my fraction, I can already put my numerator. Down 4 means it's a negative 4. And then the red line, again, I always make mine go to the right, not that you'd have to. But how far to the right does this go? Starting right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good, if I went any past that, I'd have to use more fingers. But I went to the right 10, and since it's to the right, it's a positive 10 right there. Now, just in case you were wondering, if you went to the left and then up, it would have just made the 10 negative. That's it. And in the future, if for some reason you ever need to go down and to the left, well, that would put 2 negatives in your fraction, which would make it then positive. But this one isn't, of course. So this fraction can clearly be simplified if we divide both of these by 2. Or you could say, I'm just going to put in the calculator, hey, that's good too, man. So now it's negative 2/5. And that would be our fraction as a simplified, our slope as a simplified fraction. Well, we got to find the slope of this line. And, well, you only need 2 points, right? Just find 2 points on this line that you can actually know the ordered pairs for, okay? Well, there's a bunch on this one. And the first one I would notice is this one, the x-intercept right there. Probably for me, the next one would be this one at the very top, right here. Now, are there others? Sure. You could have said, I'm going to choose that one, or that one, or that one, or that one, or that one. You know what I'm saying? There's just a bunch. There's so many that you could have chosen. And yeah, I did miss those grid corners with some of those red dots, but I did my best. For me, though, I'm just going to use the 2 purple points that we have. All right. Now, remember, it's rise over run. So I got to figure out the change in the y values. And for me, that's how far up it goes, right? Well, if I start right here, I'd have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that's up 10 for me, which makes the numerator a positive 10. And then how far to the right does this go? It doesn't go to the right at all. That's 0. Well, if we look back, we should know that anything divided by 0 is just undefined. Which means the slope right here is so large, it is so big that we can't actually quantify its steepness. It's undefined. meaning also that this is the steepest slope that we know of. So I like these types because it's like, bam, anything divided by 0. It's one of those rules, right? Like if the 0 was the numerator and the denominator was 10, well, then you'd know it. They had 0 divided by anything is still 0, okay? I just don't get the two confused. Well, that was with the graph, right? But of course, they're going to take the graph away from us. And when we look at graphs like that, you guys, and we say, hey, there's a x-axis and there's a y-axis, and we say, there's a line right there, it's kind of pretty. Then we say, well, it goes up a certain amount and then goes to the right a certain amount. We're finding those changes in the y value and x values, and then finding those as a ratio, well, just a fraction that we simplify. But then we run into this question, well, if we don't have a graph, then what are we supposed to do? Well, how do you find the change in the y's and the change in the x's? And some of you guys look at these two ordered pairs that they've given us, and you kind of know what we're talking about right here. Well, if you want to find the change in the y values, it's distance. It's distance between two values. Distance is difference, which is subtraction. So you take one of the y values and then subtract the other one. And it's the same with the x values as well. If you want to find distance between any two values, you subtract the two values. Okay? Well, what this means is on this particular set of points, we got to find the y values, their changes, so we're going to subtract them, and then we'll find the corresponding x values and their changes, and then we'll determine the slope from there. Okay? So just remember, it's always a fraction, right? It's a ratio as a fraction. And we want to find first the change in the y values. Well, you try to make the color coordinate on this, okay? Now, it doesn't matter which one you go from. You can go from 1, 4 to negative 2, 6, or you can go from negative 2, 6 to 1, 4. So it doesn't matter which values you put first. And that's kind of the great thing about slope is, since it's a constant rate of change, it makes it a straight line. So straight lines, it doesn't matter which order you put them in, the rate of change or the ratio of change will always be the same. So here's what I mean. If I just did this straight across from left to right, first point to the second point, I'd say I would want to find the change between 4 and 6, right? Now, that would be subtraction, and 4 minus 6 is negative 2. All right? And then I'd say, well, what are the changes in the x's? Well, that's my horizontal change. That's the run. I'd say, well, it's 1 and negative 2, but since I'm finding the change between the two, it's a subtraction problem. And the subtraction part is crucial because right now we're subtracting a negative, which really means that this becomes a plus, right? 1 plus 2 is 3. Now we have negative 2 over 3, and that can't be simplified any further, so this is just our final answer for the slope on this one. These 2 points were given to us, 1, 4, negative 2, 6. So if you guys were thinking, just like we did on those last 2 examples, hey, I just want to graph the 2 points, I can find it that way, you could. Right? This is, well, I don't know if it's, I would say it's quicker, but if you feel more comfortable graphing it, then you definitely could do it that way. Because even though we're saying, this is a way, it's, as far as I remember, even on the homework, they don't require a specific method. So yeah, if you wanted to graph it, it's just keep in mind if you guys are committed to graphing these, when these numbers get bigger, it can be a little bit more complicated to graph them, that's all. So yeah, let's bring up that point, right, where let's say that we know it's subtraction between the two because it's always subtraction. That's how we find the difference between two values. Let's say that we switch up the points, right? So we did 6 and 4 there, and then negative 2 and 1 there. Now, some of you guys know what's going on here. It's going to be the same fraction. It's just going to show up slightly differently. 6 minus 4 is 2, and negative 2 minus 1 is negative 3. It is exactly the same. It's just changed where the negative is. That's all. So it doesn't matter where you put the negative, as long as there's only one, you guys. Of course, if there were two negatives, then it would make the answer a positive. But yes, it does not matter where you actually put the negatives on these. They still remain the same or equivalent value. All right, here's another one. We want to find the slope of these two. We got 15, -9, and 10, 4. You know, you guys take a minute and see if you can solve this one for the slope. All right, 1 minute, go. Now, if you guys are still working on that, keep working. I'm going to start on it though. All right, and then you guys can check your work with what we get on this. So yeah, it is a difference between x and y values. Y is in the numerator, x is in the denominator on this. And again, it doesn't, just like we saw in that last example, it doesn't matter which one goes first. So I got my two y values, -9 and 4. We'll just list them, -9 and 4. And yeah, we could start on the math on that, right? -9 minus 4 is -13. And then we have the x values, 15 and 10. So we're going to subtract those as well. 15 minus 10 is 5. Now, again, I wouldn't change this into a mixed number because it kind of jacks up at least the rise. So I'm going to keep it as -13/5. Now, just in case you were wondering, is there a way we can use the calculator on this? Yeah, sure. Remember the fraction button on this, n/d? And you just click it, then you type in -9 minus 4, and that's my numerator. And then you scroll down using this cursor function right here, right, the oval, and then you just type in 15 minus 10, and it will actually do all the work for you. And if it needed to be simplified, it would, of course, but this one didn't, right? It just shows up directly as a -13/5. It's just, you know, the calculator shows it, I guess, more like right here, right? Something like that. So, but again, this is pointing out the fact that it doesn't matter if the numerator or denominator is negative. Only one of them is, so the whole fraction itself, we could say, is negative as well. Well, this brings up the slope formula, or equation if you'd like. Keep in mind, too, the way that I have this written, for some reason a long time ago, they were like, we're going to put y2 minus y1 and x2 minus x1. It doesn't really matter, you guys. Just like we've seen, right? It doesn't matter which one is which. So if you see it written that way, it is the same thing. They've just switched the numbers around, and like we've seen before, it doesn't. You can switch the points around, so it doesn't really matter which is which. Just as long as they correspond with each other, right? Like this x and y value are from the same ordered pair, and this x and y value from the same ordered pair. That's the only thing that really makes a difference. But there are other ways, and I'm going to show you guys a different way to do it. I know we've seen graphs, and then we've seen this formula way in those last two examples. But I'm going to show you a different way, and if you like it, use it. If you don't, then ignore it. In fact, if you like what we've already seen, I would kind of recommend ignoring what we're going to do in this next problem. And you know, you should be able to get the same answer using the formula anyways. So here's our ordered pairs. We got 15, 5, and 4, 8. And all we want is a slope on this, okay? Well, we can figure out the slope pretty quickly by just finding those changes. So here's what I mean is I'd say, here's my y values, 5 to 8, right? Well, to get from 5 to 8, you'd have to go up, so that's a positive 3, right? Or in other words, 5 plus 3 is 8. So that's my numerator, 3. The denominator is the x values and their change, right? So from 15 to 4, it's always addition and subtraction this way also. So 15, what do you got to do to 15 to make it 4? You'd have to subtract 11. And that's our denominator. Bam. Now, was that pretty much the same? It is. It's just sometimes if these numbers are a little bit clear like they are in these examples, then the formula, it may just take a little bit longer. But if you understand it better than this one, then it doesn't matter. That's okay too. I do have the negative in the denominator, and again, that doesn't make a difference either. Yeah, we're gonna see that, I think, in the future. All right, here's a good one. So you guys have seen 3 methods: graphing, the formula, and then I call that rainbow method with the rainbow above and rainbow below. It's very pretty. But you guys see if you can find this slope as well. We'll give you guys another minute, okay? 1 minute, go. All right, before we do this one, we'll do it together. Most students prefer the slope formula when solving for the slope and given 2 points like this. But what do you guys want me to do on this? All right, formula method it is. And like I said, that's pretty much the preferred method as well. So I got my two y values, 5 and -1, right? And it's always subtraction between the two. 5 minus -1. And, you know, whether you do it now or later, that's minus a negative is going to make that a plus. And then our x value is 6 and -6. So 6 minus -6, right? Which also is going to change into a plus. So the numerator, 5 plus 1 is 6, and the denominator, 6 plus 6 is 12. Yeah, both of these can be simplified by a factor of 6, right? Divide both sides by 6. And we get 1/2. Bam. Now keep in mind that if you had switched those, right? If you did -1 minus 5 and then -6 minus 6, it just would have made both of the numbers negative, right? It would have been -6 over -12, which in turn would have become a positive anyways. So there's 3 different forms for equations that we're going to be looking at. Now, this last one right here, this is called point slope form. And the reason it's called point slope form is because it gives us a slope, and m is the slope, okay? So whenever you see m, and by the way, I don't know why it's m. I think maybe the Greek word for slope may start with m, but I have no idea. Just some time ago, some math nerd probably was like, hey, slope is m. And then everyone wanted to beat him up, okay? But in any case, m is the slope. And just like we saw with the slope formula, it's got an x1 and y1. This would be replaced, the x and y right there, those would be replaced with the x and y values from point. So that's why this is called point slope form, because this is how you would solve for an equation when you have been given a slope, m, and then the point, x and y. All right, so that's why it's called point slope form. And it bothers me that it's written differently, and they force you to write it in the homework, but you may see it written like this. I just don't like it because it does add a step automatically. But if you keep it the way that we have it up here, it takes this one. If you keep it like this, then it takes away this step of adding the y value to both sides at any point, okay? Because we already know how to distribute and then combine like terms, so this one shouldn't be a problem. Now, the one we really like is slope-intercept form because it gives us a slope. Again, that's m. And then the y-intercept is, the b value is the y value of the y-intercept. So the y-intercept itself would be written as an ordered pair of 0b, right? But then this automatically gives us the y-intercept, which by itself is also a point. You know, I mean, this, you could graph the y-intercept and then use the slope to figure out other points on the graph. Well, standard form is a little bit less commonly used, I guess, in like straight math classes. Generally, we manipulate an equation like this into slope-intercept form. Okay, but if you wanted, right, like a would be a coefficient of x. That'd be a number right there, like 4x plus 5y. Then 5 would be the b value, equals, I don't know, 20. Doesn't matter. And then you could find the y-intercept by just taking the c divided by b value, the x-intercept by taking the c over the a value, and then the slope is just negative a over b. All right? So these letters, C, A, and B, they would represent numbers, generally speaking, okay? And then, of course, slope, that's M. M is for slope. Again, I can emphasize that so often, and I would still feel like it's important to emphasize it, okay? Welcome to math, man. So And the y-intercept, you can figure it out. This is a formula as well. You can take a y value, subtract the slope, multiply it by x, then you automatically get your y-intercept. And that's just a manipulation of this formula right here, y equals mx plus b. Y equals mx plus b, it's so common, I'm sure they've used it in Jeopardy once or twice. Just remember, this is the main one we're looking at right here. Y equals mx plus b. M is the coefficient of x. It's being multiplied by x. We know because it doesn't show the operation there. So if you can just find, if it's in this format, y equals mx plus b, just find the coefficient of x. There's your slope. And then the y-intercept is just the b value. To expand on this one a little further, these are different forms of equations. This is I'll try to highlight these. This is what we call standard form right here. The one we're looking at on this example is slope-intercept form. And then later on, and we're going to see this one, is point-slope form. So standard form doesn't really specify what either of the intercepts are, or the slope for that matter, which is why some manipulation we may see happening of these in the future. And then slope-intercept form, though, it gives us the slope immediately as m, and then the b is the y-intercept. And then point-slope form, of course, we'd use the points and the slope to simplify this, and we will. We'll be simplifying point-slope form into slope-intercept form. So the main one we really like is slope-intercept form, at least when we're graphing straight lines. Yeah, and I'm not the one that made up these, obviously. I mean, I'm pretty nerdy. I'm just not quite that nerdy. But this lowercase b and that uppercase b, yeah, they are different. So here we go, right? This is a linear equation. Identify the slope and y-intercept. Write your numerical answers as whole numbers or reduced fractions. Write your intercepts as ordered pairs. Always write your intercepts as ordered pairs, because this one, and this is a nice thing about this one, by the way, it's written in slope-intercept form, right? We got y equals mx plus b. Now, I know that's minus 7, by the way, but I can at least see that the negative 8, that's the coefficient of x, so that's our slope. Slope is always the coefficient of x, as long as it doesn't need to be simplified, and as it's in this format, it's just negative 8. Now, if you wanted to write negative 8 over 1, that's fine, so that you can see the rise and the run. That's good. I'm not going to, because I don't want to simplify that further. I do want the y-intercept, right? So the y-intercept, it's just, and yes, intercept's a long word, so I'm not going to write it all out, sorry. Just remember, it's an ordered pair, and the x value is always 0, okay? The y value for the y-intercept, I'm trying to fix that y, is just whatever's being added or subtracted to your x's. In this case, it's negative 7, so the y-intercept is 0, negative 7. Now, I almost feel like I've overcomplicated this, okay? Because when it's in this format, y equals something times x plus or minus something else, you are automatically given your slope and y-intercept, just like we saw in this example. Oh yeah, yes. And I apologize for my handwriting. That is a 0 right there. So let me explain this a little bit more, you guys, on this one, okay? So if we were to look at a graph, because the ordered pair really comes from the graph, right? You'd say, well, where is 0, negative 7? Well, you know it's down here, right? 4, 5, 6, 7. It'd be about right there. And then your slope being negative 8 means it would be pretty steep like this, something like this. Okay? But yeah, the ordered pair, 0, negative 7, the y-intercept always has a 0 x value because it's right on the y-axis. It's always going to be on the y-axis, which is why we call it the y-intercept. And again, we'll be looking at the x number line, and this value is where x is 0. All right, okay. All right. Just look at this. Just look at this equation, right? Y equals negative 7x plus 2/5. It's not asking us to graph. We just want to figure out what the slope and y-intercept is. Now, before we do that, though, we had those 3 different forms of equations, right? Got standard form and slope-intercept form and point-slope form. I want you guys to know what form of the equation we're looking at. Now, ax plus by equals c. It's definitely not in that format because the x and y's are on different sides of the equal sign. Y equals mx plus b, yeah, I could see that. Then again, the point slope form had the y's and x's on different sides, but it had parentheses, right? This one doesn't have that. So hopefully we know right now that this equation is in slope-intercept form. Which means, right off the bat, I should be able to get the slope and the y-intercept. And those are the two things that it's asking for, slope and the y-intercept. Well, if we can find them very quickly without any calculation at all, we just have to identify where they are in the equation, right? And the slope, is the coefficient of x. It's the number being multiplied by x, which in this case is -7. Well, what about the y-intercept? Well, the y-intercept is what is being added or subtracted to the x's. Just don't forget to make it an ordered pair. So 0 is the x value. And I see it's adding 2/5. Since it's adding, it's positive, and we'll just write this in as 2/5. There we go, slope and y-intercept. Now this one looks a little different, right? It's definitely not in standard form, because it's not x and y's being added or subtracted together. This one actually is in slope-intercept form. Let me show you guys, right? Y equals mx plus b. M is the slope, and then b is the y-intercept. Now, what it's missing on this one, or at least it's not showing, is the plus b part of this. Well, as we've seen before when we were solving equations, there are such things as phantom values. Now, this one would have to be addition, right? So if it can't be a phantom 1 because that's only for multiplication and division. So for addition, that is a phantom 0 on that one, okay? So this allows us to see that the slope is the coefficient of x, which in this case is -11. So the slope is -11. And the y-intercept, even though it wasn't showing, it was still there. We just couldn't see it. The y value right there is just that 0 in the y-intercept. So this one just happens to go through the origin. Oh, I missed a 1 on that -11. There we go. So the slope is -11, the y-intercept is 0, 0. So be careful on those. Those phantom zeros, and even phantom 1s for the slope. Sometimes they get people when it asks for slope and y-intercept, but they are there. They're there. They're always there. They're watching, which is why they're so creepy. We still want slope and y-intercept on this, guys. So, take 30 seconds. Just see if you can identify the slope and y-intercept on this one, all right? 30 seconds, go. I hope you guys got this down, right? We want the slope, and we want the y-intercept. Now, I haven't figured out the y-intercept yet, but I'm going to put this as an ordered pair. I just want to fill in the y value, right? Well, the slope on this one is the coefficient of x, because it's in slope-intercept form, right? It's in this form y equals mx plus b. And m is the slope, the coefficient of x, and b is whatever's being added to it. So my slope, 7/11. And then the y-intercept is there at 24, 0, 24. I feel like there's some kind of 7-11 pun in there, but I don't know what it is. So slope is 7/11, and the y-intercept is 0, 24. So here's another example. Now you'd look at this, you'd look at this example and you'd say, hey, we don't really know what this format's in. But it's in one of the 3 major formats. In fact, this one is in slope-intercept form. This one's in slope-intercept form. Let's look at what slope-intercept form is first, okay? And we're just trying to identify the slope and the y-intercept. So y equals mx plus b, right? Well, some of you guys are looking at this equation, y equals -957, and they're like, well, I don't see the x. Well, just because you just don't see it doesn't mean it's not there, right? That's where we're coming up with this phantom stuff. Well, the x, there is an x there. The question really would be what the coefficient of x is. Now, if we just identified some parts of this, right, y equals -957 would have to show it like this. Hopefully this kind of makes sense where that negative 957 goes. Well, what about the coefficient of x then? Well, if we're not showing an x, that means its overall value has to be 0, which means its coefficient also must be 0. Okay, so there's a phantom 0 for you. Well, yeah, I don't really like the phantom values so much either, right? They're really creepy. I'll fix the 0, by the way. It kind of looks like a backwards 6. Which is why, if you'd prefer to show them, do show them. Because then, in that way, we can at least know what value is there. But yeah, that's a 0x, because anything times 0 is 0, and then we can make it a phantom 0. Well, from this, we know then that the slope is 0. And, while we're doing the rest of this, just try to think about what a line would look like that has a slope of 0, all right? We're going to see some, but just think about what it would look like. So my y-intercept, I got an x value that's 0, and the y value, of course, negative 957. Maybe I should have given myself more space. I feel like that's acceptable. 0, negative 957. And there we go. We identified both of them. And again, this is pretty crucial because in the future, when we start to graph these, even though the equation doesn't show the slope, you need to know what it would be, right? And yes, this one, as you have accurately described, is a horizontal line. Well, what about this piece of garbage? Well, it kind of looks like it could be a standard form. It definitely is not in slope-intercept form because it's not y equals, which means it can't be point-slope form either. What the heck is going on here? Well, if we went back, remember what we graphed an equation like this, right? Where x is negative 2/5, that is, well, negative 2/5 on the x number line is about right here, I'll say. And it's always x is negative 2/5. That created for us, when we graphed these types, it was a vertical line like this one. All right, now, since it's a vertical, straight up and down line, you may think, well, the y-axis also is a straight up and down line, right? That'd be this one. So when we say, well, what's the y-intercept on this one? You'd say, well, they're both straight vertical, straight up and down, so they're never going to intersect. This purple line will never cross through the black one right here, right? The y-intercept. Well, that creates a problem. That means that there is no y-intercept. Right? So the y-intercept, we say there is none. Maybe on the homework it'd be a D&E kind of thing, right? It just doesn't exist. Well, what does that mean for the slope? Well, we've already figured out the slope of a straight up and down line. And the slope is always going to be some number over 0 because this has no run. That's a 0, by the way. Since it has no run, it's an undefined slope. It's undefined. So this is a unique scenario. But it's only when you see x equals and we don't see a y at all. And you could say, well, isn't there a phantom 0y? Yeah, but we need the coefficient of y's to be 1, right? Like if you look at slope-intercept form, y equals mx plus b. Let me finish this off. Mx plus b, like this one. I should be able to ask you guys what the coefficient of y is, and you should know that it's a 1, not a 0. So if you ever end up with a 0y, like we do in this case, if you wanted to say, well, you're going to add 0y, well, that really doesn't do anything for us. Keep it a phantom value, okay? Well, this one is in standard form, not slope-intercept form, even though it's asking for the slope and y-intercept. So write your numerical answers. We'll write our answers, no problem, okay? If it's undefined or it doesn't exist, we'll write D&E. But this one does exist, right? Now, if you used the formulas that we had on that other slide, right, where you'd say, well, my slope on this one, and I'm going to do it a different way, but let's say that you memorize that stuff because it doesn't give it to you on a test. Say the slope is negative a over b, and the a value is the coefficient of x in this one, which is negative 6. So yeah, replace your a with negative 6 on that. And then the b value is the coefficient of y, which in this case is negative 12. Now you get 3 negatives in this, not a problem. 3 negatives is odd, so we know the answer is negative, and then simplified is a negative 1/2. So that's one way to find the slope with that formula business that we saw on that slide, 4 or 5 slides back, right? And then the y-intercept as well. The y-intercept could be found by taking, it was 0, and then hold it, it was c over, I think it's negative c over b. There we go. Yes. And the c value in this case is 48, right? ax plus by equals c. So we'll say the c value replaced with 48. And the b value is negative 12. We still know that's negative 12 in green there. So now we'll simplify this, and that would be 0. So that's fraction has 2 negatives. 2 is even, so the answer is a positive. And 48 divided by 12 is 4. So that's my y-intercept right there. All right. Well. So I'm going to show it this way. I would say it's impractical to do it this way, just because of all the formulas you got to memorize on this stuff. Okay. But if we can manipulate the equation in the slope-intercept form, which is what I would prefer to do, then it will reveal to us what the slope and y-intercept is anyways. So using standard form, right, we have negative 6x minus 12y equals 48. And if we go back to Unit 1, I think it was Section 9, it would be like solving this or manipulating this equation, solve for y. All right, so if you were to manipulate this for y, let's bring this up so we have a little bit more space. You'd say, well, I got to get rid of that negative 6x, right? So add 6x to both sides. And 48 and the positive 6x there, they're not like terms, so I can't actually combine those. This does zero out, and we'll drop this to make this negative 12y equals 48 plus 6x. And I know this was more than a unit ago, but hopefully it still kind of makes sense. And then from here I would say, you know what, just divide all the terms by negative 12. That's a negative 12 there. To make that a 1y, right? Because the coefficient of y is 1. In fact, we'll write this out. Y equals, now it should be in this format. Oh, dang it. Missed a part. 48 divided by negative 12 is negative 4. Going back, see, I did make a mistake. It's not negative c over b. If you look at the top right there, the y-intercept, it was not negative c over b. It's just c over b, actually. So I didn't really need that first negative, which means it was negative 4. And I noticed that here at the end. I got negative 4, and then it would be plus 6 divided by negative 12. We'll write that as a negative 1/2 x. Now, the two terms right here, and yeah, I don't really need the plus sign there. It's we just make that a minus 1/2 right there. I could rearrange these two terms, right? I could say y equals negative 1/2 x minus 4. Well, why would I want to do that? Well, because then it's in formal slope-intercept form, whereas before like this, I was just using, right here, I was just using principles of equality to make this. But you can shift and move around these terms as long as they keep their equivalent value. So this was negative 1/2 x. This is still negative 1/2 x. That's negative 4. This is still negative 4. So I'm keeping the values the same. And what does this do for me? Well, it's in slope-intercept form, so I can immediately identify the slope, which is negative 1/2, just like we found above. And then the y-intercept is 0. And then the b value, which in this case is negative 4, just like we found like I fixed that it was above with this negative 4. Okay? That's what I recommend doing when you see these in standard form. Manipulate them. Use what we did in 1.9. By the way, the the process is essentially the same. You always get rid of your x's and then divide all the terms by the coefficient of y. That's it. And you will have automatically, pretty quickly as well, as long as you rearrange this, slope-intercept form. All right, parallel and perpendicular lines. Because I think we got to write equations for these. I forget. Maybe we're just identifying the slopes for them. But in any case, parallel lines. Just think about a parallel line on a graph, right? Like if you looked at a graph, there's my x-axis, there's my y-axis. If you have this line right here in purple, and if you had a parallel line like this, just think about, and I know those aren't exactly parallel, but I did my best. But just think about the slopes between these two, right? Well, the slopes between the two, right, rise over run, they're exactly the same, which is what makes them parallel, actually. The only thing that's different between these two is the y-intercepts are different, right? Like this one has y-intercept there, and this one has y-intercept there. Different y-intercepts. But the slopes are the same, which is why they're parallel. So those are the only two conditions we need when we think about parallel lines. Slopes are equal, y-intercepts are different. Now, perpendicularity, I don't know. That seems pretty formal. Perpendicularity, I guess. Well, if you had the purple line, something like this one, okay? Perpendicular means that it's going to create a 90-degree angle with this. And 90-degree angles are usually shown with a little box like that, usually. The slopes on these ones, okay? In order to make lines perpendicular, and again, we're just looking at the slopes, you're going to take the opposite reciprocal of the slope of one line to find its perpendicular slope, okay? The y-intercepts don't matter with perpendicularity. So let's do this a little abstractly, okay? So as a fraction, you'd have slope, right? Rise over run, a over b, I guess. Rise is a, run is b. Well, for a perpendicular slope, you need to have an opposite, so that would make where this one, I'll say, started out as negative. Started positive. It becomes negative. Okay, that's its opposite. And then the reciprocals where we flip the fraction, kind of like you would with dividing fractions, So whatever you start out with, flip the fraction and then change the sign. Then you have a perpendicular slope. So on a problem like this one, we want to find the slope of a parallel and a perpendicular line, no problem. But we don't know the slope or the y-intercept on this one, and again, you could use the formulas, but I prefer, and I think you guys probably prefer, to see this in slope-intercept form, right? So get rid of your x's, so minus 9x, and like I said, you can flip them later, you can flip them now if you'd like. 4y equals, I'm going to flip them right now. We had a negative 9x and then a positive 12 right there, right? Well, then divide all the terms by 4 to get y equals negative 9 fourths x plus 3. Now, the plus 3 doesn't really make a difference because this is only asking for slopes of parallel and perpendicular lines. So the plus 3 doesn't really make a difference, but I did it anyways because it was so fun. What I do like to see on this is the slope of this line, which is negative 9 fourths, right? Well, a parallel line has exactly the same slope, so it also would have a slope of negative 9 fourths. The perpendicular slope, though, would be the opposite, so it's going to be positive, and then flip the fraction to be 4/9. There you go. This slope is perpendicular. This one is parallel. Let's go over this one too. Parallel and perpendicular slope. And yes, when I speed it up, I tend to make more mistakes. So you guys will please watch out for that on my behalf, and I apologize in advance for those, any that are made. Let's get rid of the negative 3x there. Add 3x to both sides. And again, these are not like terms, so I can't combine them. So still got the 4y, and I'm going to switch these right now to be 3x minus 24. Now divide both sides by 4. Well, all the terms by 4. So that becomes y equals 3/4 x minus 6. Again, the minus 6 we're not so worried about. and I can identify my slope because it's in slope-intercept form. A parallel line would have the same slope, 3/4. A perpendicular line would have the opposite, so it's negative, and then flip the fraction, 4/3. Perpendicular slope, parallel slope. Bam.